All right, so we're back, and I'm just continuing from where I just left off moments ago. And I'm moving on to 1J. 1J looks to me, when I see a factorial, it shouts to me ratio test. It's my first instinct every time. So when I see any kind of factorial, I know they get in the way. They get ugly, right? Factorials are really hard to work with unless you can cancel out the factorial. And that's the beauty of the ratio test. It cancels out that factorial. So this can get a little bit ugly. I mean, it's not really that relevant, but we'll write it all out. So this is the kind of n plus 1 term. And then, so that's a sub n, right? That's a sub n plus 1. Now a sub n is just going to be n squared plus 2n plus 5. So we're evaluating this, and we want to see, is this ratio less than 1? If this ratio is less than 1, we converge. If the ratio is greater than 1, we diverge. Again, folks, I'm going to flip and move things around at the same step, okay? This is the numerator. Oops. This is the numerator. That's the numerator in the numerator, and this is the denominator in the numerator. Now I'm going to take the denominator, I'm going to multiply by the reciprocal. So the reciprocal is going to be n factorial over n squared plus 2n plus 5. I'm going to put the n factorial here, and I'm going to put the n squared plus 2n plus 5. You don't have to do this in one step. I did it in 2 steps earlier, but this is just going to be easier for us to see. And then what's going to happen now? Well, this whole thing is going to be n squared plus 2n. It's going to be like 4n, I think. There's going to be a plus a 1, plus a 2, plus an 8. I mean, I'm doing all this work. It's completely irrelevant, right? Some of you are like, why are you doing this? Because it's completely irrelevant, right? All that expanding I did, it's completely irrelevant. Why? Because if we're going to infinity, all we really care about is this part right here, right? The highest degree. And that's going to 1. So therefore, this part is going to equal 1. Now what about this guy right here? Well, this is why the ratio test is so brilliant, right? The ratio test has this beautiful thing with the factorials that they cancel each other out. This is going n to 1. This is going n plus 1 to 1. So what are we really left with? We're really left with this part here. It's just really this. What happens when n goes to infinity? It approaches 0. Oh, wow. So this is 1 times 0, right? And last time I checked, if rho equals 0 and it's less than 1, guess what, folks? By the ratio test, we have convergence. Awesome. Now, when you're looking at those, I got to tell you, the ratio test is often your best bet when you have factorials. They can get kind of challenging sometimes, but I'm going to go ratio test is my first bet. When I see a factorial, it's my first bet. Now, this one here is a challenge problem. Frankly, if you didn't do this one, that's totally fine. In fact, if you want to skip this part, that's totally fine too, because I look at this and I see, wow, this one's going to be kind of has like the n is telling me to do the root test, the factorial is telling me to do the ratio test. Yeah, this is a challenge problem and a half. So you can skip if you want, but I'm not going to skip it. I'm here. I have nothing else to do with my time. So I'm going to pull out the ratio test. Huh. Okay. This is not going to clean up that nicely that quickly. This is causing me a bit of a headache right now just looking at this. Oh, wait a second. That's cool. Oh, that's neat. We get one of these in the numerator, right? I'm going to just, separate this out real quick. This is going to be kind of cool. Oh, wow. See what happened here is the n plus 1 factorial over the n factorial just turns into n plus 1 in the numerator. But I have n plus 1 to the n plus 1 here. Well, in order to make these have the same exponent, I'm going to take the 1n plus 1 and bring it over here, and they're going to cancel. And that's just going to leave us with... Wow. Oh, that looks like E. Looks a lot like E. In fact, it is E, kind of. Oh yeah, that's kind of neat. Hopefully you'll see that. That makes sense? Just took the reciprocal, the stuff on the inside, and got a -1 there. And the cool thing about those exponents, those rules, we can do a little bit of magic here. We can say this. It's not really magic, folks. That's going to be e to the -1. Again, if you didn't see this, if this is not making sense, you can watch the other video that I posted on the channel that says the definition of e. But that's what shows that this equals e. So if this equals 1 over e, and the ratio test, oh, that's sweet. So the ratio test says if rho, this is rho, right? 1 over e is rho, is less than 1, we have convergence. Wow. Okay. Again, challenge problem, not something that you need to be worrying about. If that's something that you are, don't let that keep you up at night. Okay, folks? That is not the kind of stuff that I don't expect you to do on a regular basis. Okay, we're moving on. That's kind of fun. Okay, this one is screaming for me to do the root test. I mean, when you have some expression to a power of n, it just says that should be calling you. That should be saying, hey, use the root test, please. So the root test says, let's find what this is. That's what the root test says. The nth root of something to the n, that's why we're doing this whole thing. That's why we're using the root test. It's going to be n squared. They just cancel each other out, like 1 over n and n, they cancel each other out. And this is rho, right? And if rho is less than 1 for the root test, therefore we have converge by the root test. So those n's just shout for you. Whenever you have some kind of expression here that's a function of n, has some kind of variable in there to the power of n, that's just screaming for you to read the root test. This is kind of screaming the root test too, except for, no, this isn't a root test because there's no n in the middle. You don't have to worry. You don't have to take the limit. This is a geometric series, folks. This is a geometric series. Where r equals 1 over oh, that's kind of neat. You could actually figure out the sum of this. You can figure out what it converges to. Assuming, of course, that, well, r has to be less than 1. I should say the absolute value of r has to be less than 1. This is going to be positive, so it's definitely r is less than 1. Okay, so, is this less than 1? Well, that's like asking, is 1 less than 2 ln of 2 minus 1, right? And that's like asking, is 2 less than ln of 2? Is 2 less than ln of 2? Well, 2 ln of 2, ln of e is 1, right? ln of 2 is definitely less than ln of e because e is like 2 point something. So ln of 2 has got to be less than 1. So I don't think this is the case, right? I should put a question mark over these, right? Because this is what we're testing. I don't think this converges. Because I don't think this is less than 1. How can that be? 2 ln of 2 minus 1. I mean, I could pull out a calculator, right? I could pull out a calculator. In fact, I think ln of 2 is something around 0.693 or something like that. So if we did 2 times that, it's going to be, what, 1.38. So 1.38 minus 1 is 1 over 0.38 is greater than 1, right? So, but we didn't have our calculator. We'd have to know 0.69 if we just thought about it this way, right? So it doesn't look like this is less than 1. Therefore, if it's not less than 1, right, this is not the case, right? R here looks like it's greater than 1. And therefore, what do we have? We have a diverging series, folks. Wow. Yeah, it's pretty tricky with the 2ln 2 and all that kind of fun stuff. I mean, for those of the people that had calculated, are like, that was really easy. But you got to figure what that R is. Oh, love this one. This looks awesome. This looks totally awesome. I don't even know why I'm writing it out. I'm going right to the ratio test on this, folks. Actually, I might not. Yeah, I could go right to the ratio test, but there's something, this can be simplified first. This could be simplified because I could say, well, instead, let's rewrite this. Well, this can be simplified a lot because we have really n plus 3, n plus 2, n plus 1 all over 6 times. I mean, that's what this turns into, right? I mean, I could go right to the ratio test. I probably should have because it might have been even cleaner. But this is pretty clear to me that that's what this turns into. So now if we do the ratio test, I don't know if it's cleaner or not, but we're just adding 1, right? That's a sub n. And now, that's that's a sub n plus 1. And that's a sub n. A lot of stuff's going to cancel, right? The 6's are going to cancel. The n plus 3 and the n plus 2 are going to cancel. I mean, I'll write them out just for you keeping score at home. There's going to be cancellations left and right. Whoop, 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 whoop. Now this over here is going to approach 1. This here is going to approach 1/3. If rho equals 1/3 and 1/3 is less than 1, we have a converging series by the ratio test. You didn't need to do the simplification first, folks. You could have gone straight here if you wanted to. Might have even been cleaner. But that's the way I was looking at it, at least. And I thought it was still works out to be the same answer. So it's kind of neat. So that's the end of the assignment. It took me a total of about 45 minutes plus the delay that I took while I was trying to figure that out. So yeah, it's not a short one, but that's why I and K are optional. If you take out I and K, hopefully it was manageable. And we are going to start assignment 3 next. In fact, we're not going to do the end of assignment 2. We're going to move into assignment 3 to alternating series. And I look forward to talking to you folks in a short while. Have a good one.